Jai Hind. Myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Through this video lecture, I will discuss the complex topics of the subject renewable energy sources, and the subject code is KOE 074. In this lecture, I will discuss one of the complex topics of this subject is geothermal energy. So, these are the contents of my lecture. First of all, I will discuss what is geothermal energy, means introduction about geothermal energy. Basically, we can say that what is geothermal energy. Then, origin of geothermal energy, how geothermal energy originate. Okay, I will discuss. Then, classifications of geothermal energy, means in this topic I will discuss different classifications of geothermal energy. Then, advantages of geothermal energy, what are the advantages, then what are the disadvantages of geothermal energy, then what is the environmental impact of geothermal energy. Okay, then I will discuss potential of geothermal resources in India. So in this lecture I will discuss these following topics one by one. So in subsequent slide, I will discuss, first of all, I will discuss what is geothermal energy, then what is the origin of geothermal energy, then what is the classification of geothermal energy, then what is advantages, disadvantages and environmental impact of geothermal energy, and in last, I will discuss what is potential of geothermal resources in India. So first of all, what is geothermal energy? Geothermal energy क्या है? तो basically geothermal energy is a form of renewable energy. It is also one of the form of geothermal energy, renewable energy. And what is renewable energy? The energy which is inexhaustible in nature is called renewable energy. So geothermal energy is also a type of renewable energy, having the source of natural heat inside the earth. Means the basic source of geothermal energy is heat occur inside the earth. Yani ki by using the natural earth occurs inside the earth, we will produce electricity, and this type of energy is called geothermal energy. Then it is renewable since the earth interior will continue to energy having high energy density. Means what is renewable? Which is inexhaustible in nature. It's called renewable. And geothermal is also one of the renewable energy resources. Means the heat occurs inside the earth is inexhaustible and it is natural. So geothermal energy, we can say that geothermal energy is renewable form of energy. It is inexhaustible like solar or wind energy. The geothermal energy in the form of heat energy can be utilized economically and efficiently for power generation and other applications with the existing available technology. Means the natural heat occurs inside the earth is, we can say that by using the natural heat occurs inside the earth, we can produce electricity, we can use this type of heat by other applications also. Okay. Though the amount of thermal energy within the earth is very large, useful geothermal energy is limited to certain site only in the world because of the feasibility to access and extract heat. means ki feasible amount of geothermal energy is limited. Okay, feasible amount yani which is accessible, yeah, which can use for production of electricity is limited. So we can say that ki geothermal energy is limited in the terms of their feasibility. Then the sites from where the thermal energy can be extracted are called geothermal field. Clear? What is geothermal field? Geothermal fields are those areas where thermal energy can be extracted. Is called geothermal field. So the commercial utilization of this energy started first in Italy in Lardello in 1904. The first commercial use of geothermal energy is started in Italy country and city is Lardello in the year 1904. Then after then the other city is Lardell 1913, then Iceland 1930 and other part of the world by 2000. Yani ki it will first it started in 1904. In India, about 50 shallow wells are drilled for steam production in Jammu and Kashmir belt. So we can in India we can say that there are 50 shallow wells are present where we can use this shallow wells for production of electricity. The thermal springs are found in different parts of India, that is Himachal Pradesh, Maharashtra, Cambay of Gujarat, Uttar Pradesh and some parts of Bihar and near Jawai in Assam. So these are some areas where thermal springs are found. It is also one of the types of geothermal energy. Then what is the origin of geothermal energy? So basically the earth's interior having mass of hot liquids, gases and steam is cooling slowly and the temperature of the earth's core is estimated to be about 40,000 degrees Celsius. Okay. Then what happened? The average geothermal heat dissipated from the land is about 0.06 watt per meter square as compared to solar heat energy of 1 kilowatt per meter square. Then below the solid crust is the molten mass called magma, which is still in the process of cooling. The earth vibrations cause the magma to come near the earth's surface, thus causes active volcanoes, hot springs and geysers water exist. Okay. Then these hot magma near the surface solidifies into igneous rock. The heat of magma is conducted upwards into this rock and groundwater that finds its way down to this rock through fissures in it will be by the heat of the rock, yeah, by mixing with hot gases and steam emanating from the magma. Okay. Then what happened? The heated water will then rise upward by convection into porous and permeable reservoir above the igneous rock. It is covered by the layer of solid impermeable rock and it traps the hot water in the reservoir called hydrothermal field. Then what happened? A well made by drilling hole in the upper crust in the region of the geothermal field can be used to trap steam for use in a conventional power plant. The steam originating from magma is called meteoritic steam, largest source of geothermal steam. So what happened? By the help of this meteoritic steam, we can use this steam for the production of electricity, and this is the main source, a largest source of geothermal energy. This is the origin of geothermal. This is the figure, typical figure of geothermal field. In this figure, this is magma and this is the igneous rock. The heat is transferred from this magma to this igneous rock. This is porous rock, other word we can say this is hydrothermal field. This is called fissures, this is fissures, and this is solid impermeable rock, and this is well. Okay, here we can obtain the hot spring, and by fissures we can obtain steam, and using this hot steam and steam we can run the turbine, and turbine run the generator which produces the electricity. Then what is the classification of geothermal energy resources, system? So basically geothermal resources vary in temperature from 30 to 350 degrees Celsius and consist of dry, a mixture of steam and water, hot water only. Okay, the water is the transfer medium in order to extract geothermal heat from the earth. The below table lists the basic technologies normally used according to the resources temperature. So this is the reservoir temperature, here reservoir field, this is common use and technology commonly used. So if temperature is greater than 180 to 200 degrees Celsius, this is called high temperature reservoir, and the reservoir fluid is water or steam, and commonly it can be used commonly in power generation. And what is the technology commonly used for this power generation? Flash steam, combined means combined cycle, combined cycle means flash and binary cycle, then direct fluid use, heat exchanger and heat pump. So these are the technology commonly used for power generation when reservoir temperature is greater than 180 200 degrees Celsius. Then second one is medium temperature. What is medium temperature? If temperature lies between 100 to 180 degrees Celsius, then the reservoir fluid is water, and this type of fluid can be used for power generation, and the technology commonly used for power generation is for medium temperature ranges, binary cycle, direct fluid use, heat exchangers and heat pumps. Then last one is low temperature. When the temperature is if temperature is below the 100 degrees Celsius, then the reservoir fluid is water, and common use for this type of water is direct use, and technology commonly used for low temperature fluid is direct fluid in heat exchanger and heat pumps. Okay. Then what is the classification of geothermal energy resources? The geothermal energy system may be classified into hydrothermal, hot dry rock and geopressurized system. So three are the classifications of geothermal energy system. So the first classification of geothermal energy resources are hydrothermal convective resources. So basically these type of resources are located at shallow to moderate depths of 100 meter to 5 kilometer, and in such water is heated by contact with the hot rock and high pressurized steam is generated up to about 350 degrees Celsius. These resources are further divided into following categories depending upon whether steam or hot water is the dominating product. So with the help of dominating product, whether it may be steam or hot water, hydrothermal convective resources are classified into dry steam field या vapor dominating or wet steam field या liquid dominating. Means vapor dominating fields are called dry steam fields and liquid dominating field are called wet steam field. And by the help of hydrothermal resources, we can generate the temperature about 350 degrees Celsius. So in subsequent slide, I will discuss what is dry steam fields and what is wet steam fields. So what is dry steam fields? So in dry steam or vapor dominated system, such system delivers steam with little or no water of high pressure and temperature up to 200 degrees Celsius. This steam is used to generate electrical energy by electromechanical energy conversion. Okay. The steam extracted from such fields may contain some amount of water and solid particles, and those are removed in a centrifugal separator. So here with the help of this centrifugal separator, we can remove the solid particles and only dry steam will enter in this steam turbine. So this pure dry steam is then directly supplied to a steam turbine which is coupled to this electric generator. This is steam turbine and this is steam generator. So by the help of this dry steam, steam turbine will rotate, and with steam turbine will rotate, which also drives the this electric generator which produces the electricity. So the condenser is used to condensate the exhaust steam from the turbine for recirculation purpose of cold water. So this is the condenser which is used to condensate the exhaust steam for recirculation purpose. This cold water is either sent to chemical recovery, yeah, it is re-injected into hot field with the help of this condensate pump. So by the help of this condensate pump, we can inject this hot water, yeah, this cold water into re-injected into hot field. Okay, this is the hot field. The main drawback of these plants are the presence of corrosive gases and abrasive materials which cause the environmental problem. So this is the main drawback of the dry steam या vapor dominated system. The next one is wet steam या liquid dominated system. So in this system, the temperature range of such field is in the range of 100 to 315 degrees Celsius, and these fields deposits hot water without much amount of steam. These can be further classified and explained in following categories: high temperature wet steam system and low temperature binary fluid system. So wet steam or liquid dominated system can be classified into high temperature and low temperature wet steam system, and by the help of this wet steam system we can obtain the temperature nearly 100 to 315 degrees Celsius. Then what is high temperature wet steam system? This is high temperature wet steam system. Here the high temperature wet steam systems having resource temperature above 180 degrees Celsius is suitable for power generation. Okay. In such system, the hot water with steam at high pressure and high temperature is extracted by deep wells drilled into the ground. So these two are the deep wells. One is production well and other one is injection well. So by help of this production well, the hot water from underground from a depth of about 1 kilometer at a high pressure reaches the well head at lower pressure, and this process produces two-phase mixture having the steam of low quantity, and this mixture is feed to flash chamber या brine separator. This is flash chamber या brine separator, which separates dry steam from brine, which separate dry stream from brine, and this dry steam is supplied to this steam turbine, and this steam turbine is coupled to a generator. This is generator, and this generator produces electrical energy. Okay. Then the hot brine is re-injected into the ground along with the steam condensate from the condenser. So this hot brine and this cold water is re-injected into the hot ground. Okay. So this is the working of high temperature wet steam system. Then next one is low temperature binary fluid system. This is the low temperature binary fluid system. In this, hydrothermal resources, these hydrothermal resources are available in the temperature range of 19 to 170 degrees Celsius, and which is not suitable for production of two-phase mixture of steam. In such situation, to utilize this geothermal heat, a fluid of low boiling point, example isobutane, is used under pressure in a primary heat exchanger. So this is primary heat exchanger. So here a low boiling point fluid like isobutane is used under pressure, and this fluid vapor generated is passed through a turbine where it expands, and the mechanical power of the turbine is converted into electrical power by the help of generator. So this vapor isobutane is sent to this steam turbine, and this steam turbine coupled with this electric generator, and this electric generator produces the electrical energy. The exhaust of the turbine is passed through a heat exchanger and condenser where it is cooled, and then condenser. Here this is the condenser. The thermal fluid after transferring heat is re-injected through a well into the ground. So after production of the electricity, the cold water from the condenser is sent back to the re-injection well. So this is the working of low temperature binary fluid system. Then second type of geothermal, second type of classification of geothermal energy system is hot dry rock या HDR या Petro geothermal system. So in this hot dry rock receives heat energy from molten rock known as magma, and these reservoirs are artificially created by fracturing deep compact rocks up to depth of 8 to 15 km by hydraulically या chemically या nuclear explosion for injecting high pressure water. Okay, and this water is pumped into the fracture well and withdrawn from another well known as production well to extract heat to generate steam for power production. So this is re-injection well and this is production well. Okay. So here water is injected, and with the help of this geothermal reservoir, this water is boiled and produces steam, and this steam is extracted with the help of this pump by the help of this production well and sent to the heat exchanger, sent to the power plant. Okay, and this steam is used to for the production of electricity. So to prevent the mixing of water in the reservoir, the depth of production well is kept slightly less than the re-injection well. Okay, so this is the hot dry rock या Petro geothermal system. Then the last classification of geothermal energy resources are geopressurized system. So these reservoirs were developed by sand deposits carried down by rivers and entrapped brine and natural gas at the depth of 4 to 6 km and are located at different levels at different places. These systems comprise of heavily compressed sediments that contain heat, methane, and pressurized hot water. When well is drilled in this zone, the reserve energy comes out in the form of high pressurized water having temperature about 160 degrees Celsius and heat and natural gas, which are useful for power generation. These sources have been found in offshore wells in Texas and US Gulf Coast areas. So this is the all about for geopressurized system. Then I will discuss what is main features of geothermal energy. In this, I will discuss what is advantages, disadvantages, and what is environmental impact of geothermal energy resources. So first of all, I will discuss what is advantages. The first advantages of geothermal energy is it may be used in both energy supply with power generation and direct heat use. So it can be used as a power generation and direct heat use. Then it is an inexhaustible source of energy. It is almost free of pollution. It is independent of weather condition, and it is more reliable source of power generation than other renewable energy resources. So these are some advantages of geothermal energy resources compared to other renewable energy resources. Then what is disadvantages of geothermal energy? The first disadvantage is it causes corrosion, erosion and chemical deposition due to the presence of sufficient amount of carbon dioxide, methane, nitrogen, ammonia and hydrogen sulfide. So this energy produces corrosion, erosion and chemical due to the presence of this. Then next disadvantage is noise pollution because of well drilling centrifugal separators. It produces noise. Then proper refilling of water is necessary. It causes settlement of land and life of plant is low compared to conventional power plant. So the life of these type of plants is less compared to conventional power. So these are some disadvantages of geothermal energy system. Then what is the environmental impact? The first one is the some part of condensable gases like carbon dioxide, hydrogen sulfide, ammonia, methane, nitrogen and hydrogen and radioactives are escaped to environment at various points and cause air pollution. So air pollution is one of the major impact on environment. Then there is possibilities of seismic disturbance because of extraction and re-injection of saline. This is one of the factor of one of the another factor. Then water pollution of rivers and lakes is a potential hazard as geowater contains high amount of dissolved solid with silica. Then another impact, environmental impact is the heat energy of turbine exhaust steam is rejected to atmosphere in cooling towers and it causes dense fog, increase in moisture. So this is the one of the another impact on environment. Then in such systems soil erosion takes place due to drilling of wells in geothermal fields, and the last one is the exploitation of geothermal energy may cause earthquake also. So these are some environmental impact of geothermal energy system. Then what is the potential of geothermal resources in India? So basically in India about 150 known geothermal sites which can produce working fluids up to 170 degrees Celsius. And the main location of such fields are, first one is geothermal fields of Puga, Chumanthang Valley in Jammu and Kashmir. Here, a pilot project for space heating involved construction of a shed at an altitude of 4,000 meter and 4,400 meter in Ladakh district, Jammu and Kashmir, and using steam at 125 degrees Celsius. So this is one of the geothermal field in India. Then second one is Manikaran, Himachal Pradesh. This project called cold storage plant has been recently commissioned by the collaboration of Geological Survey of India and IIT Delhi and Himachal Pradesh government. So this is the another project which is based on the geothermal plant. Then geothermal fields of Byas and Parvati valleys, Himachal Pradesh. The Byas and Parvati valleys are well known for their hot spring in Kullu district and Himachal Pradesh. The spring's temperature varies from 22 degrees Celsius to 59 degrees Celsius in Byas and 21 degrees Celsius to 96 degrees Celsius in Parvati Valley at an altitude between 300 meter to 3,000 meter. Then another one is Sohana near Delhi, Tua in Gujarat. So these are some areas in India where geothermal resources occur. So this is all about for this lecture. Thank you for watching.